Okay, 7-4, part 2. We are going to do examples 4 and 5. Just to refresh, the title is Rational Exponents. And we looked at identifying what it means and rewriting them from radical to exponential and exponential to radical. All right, let's take a look at the property box that we have with this particular section. And what's nice about this is they do have all of the rational exponent properties listed on the left, and then they have the numeric examples on the right so that you can apply those or see how they're applied. Excuse me. And so you can see am times a to the n. You keep your base, two separate terms. You keep the base, you add your powers. When you have a base raised to a power, and then you're have that power raised to another exponent, one base, two powers, two exponents, you multiply and keep the base, multiply your powers. AB to the m power is the same as a to the m power, b to the m power. You can separate them out. Again, negative exponent means that you flip your base. So from a to 1 over a. Just like over here, 9 to the negative 1/2 is the same as 1 over 9 to the 1/2. And 9 to the 1/2 is the same as 3. When we are dividing exponents, if they have the same base, we keep the base and we subtract the powers. And if you have a fraction raised to a power, the numerator is raised to that power as well as the denominator. Enough of review. Okay, example 4. Let's just go ahead and jump into this. I don't think it needs an introduction. Okay, so A, negative 27 raised to the 2/3. So we can do this one of two ways. I think I have found that for purposes of you guys, especially with us being fairly new to this, I think the method of doing, I'm about ready to lose my computer. There we go. Power and then root is the most beneficial and is the most easiest to understand. Excuse me. So this would be cubic root of negative 27 raised to the second power. Okay. So now going to the calculator. Oh, I did not mean to do that. Huh. Well, I'm going to have to fix that, huh? Pull this calculator up. I like this one anyway. Okay, so we're going to go down here. I don't need it in this. I need it there. Okay, number 4 is the cubic root. So I'm going to press 4. Cubic root of negative 27 and then square that and close parentheses. Hit enter and we have negative 9. Voila. I'm going to move this guy over here. Where did it go? Quite honestly, that should be positive 9 because when you square something, it becomes positive. But okay, I'm a little bit disturbed by the disappearing of my the calendar. All right, let me see if I can't. No. Okay. Let's see. Math for open parentheses, negative 27, close parentheses, squared, close, hit enter, positive 9. There we go. That's what we're supposed to get. Okay, so now I'm really glad that that happened because now I can use this to show you guys You have to use liberal parentheses, otherwise you're going to get the wrong answer. Um, and it's just a mere simple, just entering it into the calculator, and that could be the difference of getting it right or wrong. And you know, with multiple choice, there is no partial credit, especially with the ACT. Okay, now let me show you the other way to do this one. I know negative 27 is the same as, can be written as negative 3 raised to the third power. So if we have negative 3 raised to the third power, and then I have to the 2/3 power, my 3's cancel out, and now we have negative 3 squared. Negative 3 squared is just 9. Same answer, right? Okay, now over here, we need to change this decimal into a fraction. So the first thing that I need to do is I look at the place value, tenths. So that's going to be negative 25 over 10. 25 and 10 both have a like factor of 5. So then this becomes negative 5 over 2. So right now we have 25 raised to the negative 5 halves power. All right, remember negative means to flip it, right? So we flip the base. So then that's 1 over 25 raised to the 5 halves. Then this gives us 1 over square root of 25 raised to the 5th power. Do I have it set up right? Okay. Sorry. So let me grab my calculator. Here we go. Now, here's another great thing. Because this is in the denominator, I am not going to come to my calculator and do 1 divided by, and you notice I used divided by, I didn't use it some silly crazy fraction button. Square root of 25 raised to the 5th power. Because this is what I get. This is not what I want. I want this written as a fraction. So I want to know what 25 to the 5th power is. So 25 raised to the 5th power is this number, 9,765,625. I want to now know what the square root of that number is. So we're going to do second function, square root. And do you see this little bitty A and S on the calculator? And it's on most of them. And it represents the answer, the previous answer. So it's going to put this number in, 3,125. Just to show you that it does work out that way, just to prove it for my skepticals. So we have 9, 7, 6, 5, 6, 2, 5. And there you go, 3,125. So that's the square root of 25 to the 5th power. So that makes this 1 over 3,125. And that is it. Okay? I know, that's it. That's all. That's all it is. All right, example 5. Writing expressions in simplest form. Okay, look at our friends, right? We have 243a raised to the negative 10, all of it to the 2/5. So we have 1 and 2 separate terms being raised to the 2/5. Okay, so we have 2 terms, which means I should be raising 2 separate terms to that 2/5. I'm going to rewrite that out. 243 raised to the 2/5 times a to the negative 10 raised to the 2/5. Okay, so this is going to be the 5th root of 243 squared times, what does that negative tell us to do? It tells us to flip the base. So then we have 1 over a to the 10th, all raised to the 2/5. Since this is already in exponential, I'm not going to worry about converting it or anything of that nature. Pulling up the calculator, clearing this, we have math function. We're going to go down here to number 5. Oops, I don't want that. When we're doing it, we need to, if it's anything over the third root, since this is the fifth root, we're going to put 5 first, then go to math, then press 4. I'm going to get it right one of these times, guys. We're going to go down and press 5. So now it says cubic, oh my Lanta. It is the fifth root of 243 squared. Hit enter. That's 9. All of this is 9. Are you kidding, right? So now we have, this is 9 times 1 to the 2/5, a 10th to the 2/5. So a, woo, not what I wanted. I wanted that in the denominator. 1 raised to the 2/5 and a to the 10th raised to the 2/5. Okay, 10 and 5 have a like factor of 5, and that goes into that 10 2 times. So 1 to any power is just 1. And now in the denominator, we have a squared squared. So this ends up being 9 times 1 over a to the 4th, which is 9 over a to the 4th. Hopefully I didn't lose you, and hopefully that made sense. It's really not that hard. If you have any questions, please let me know. Otherwise, that concludes this particular example. Okay, just to double check. Yeah. All right. Have a wonderful day.